Hello friends, in this video we'll discuss about securely report deploying MERN Stack app into Google Cloud Kubernetes Cluster. We are going to discuss simple steps which would take less than 20 minutes to deploy MERN Stack application to GCP Kubernetes Cluster. We also dockerize the app and push the image to GCP Container Registry and run the app on GCP GKE, that is Google Kubernetes Engine Cluster. Let's get started. Before that, please subscribe and add comments and please hit the like button. So before we get started, we'll be following the steps which is mentioned in the screen. So one is set up a MongoDB collection in MongoDB Atlas, and then we install all the prerequisites in Google Cloud, like Google Cloud CLI, and we also configure all the application with reference to React Native and MERN Stack and Docker installations and so forth. And the third step is to dockerize the web application. Fourth step is run the Dockered web application for testing. Fifth step is pushing Docker image to Google Container Registry. And sixth step is provisioning GKE Cluster. Seventh step is configure KubeCTL with GKE Cluster. Eighth step is deploy Kubernetes objects to GKE Cluster. And ninth step is we will be able to see the deployed web application using a browser. And then the 10th step we'll be talking about main conclusions and so on. So let's get started. MongoDB Atlas is a fully managed cloud NoSQL database. Atlas is available in Google Marketplace and will be built under a single GCP account. So in case if you want to get it through Google Marketplace. So here I have just launched cloud.mongodb.com, which is MongoDB Atlas web application. And once you have an account created in Atlas, you can log in either using your Google Gmail account, or you can use your personal email account to register and log in. And here you can see that we are in the main dashboard, and here you can create a cluster. You can click on the create new cluster and select shared cluster, and then you might have to select the GCP since you will be using the GCP account for your application. So here you can see for the given cloud selections you can have multiple regions. So I've selected Azure instead of GCP just to give you a hybrid approach. And you can see the cluster tiers. You can see different set of cluster tiers that are available. So you can see additional settings. So basically, if you want to have the backup be created for this particular NoSQL DB, then you can mention that. So we'll change the cluster name. Currently it is cluster 1. So we will change the cluster name accordingly. Okay. So we'll keep it as to-do cluster, then create on cluster. So upon clicking the create cluster, we got an error. So probably because we already have no cluster created, so I just terminated this cluster. I just started creating one. This time I'm selecting Google Cloud. I'm selecting here Central 1, and the name of the cluster will keep it as to cluster. It's basically the application for to-do list. So let's click on create. So it is provisioning the cluster. I just have to enter the few details. So here you can notice that cluster is created. Okay, just click on browse collection. So currently we don't have any collections maintained or database of collections that are being created. We can create our own data. So click on own data, add own data, basically with the database name. So here for this example we'll be creating a to-do application. So we'll create database name as task, then to-do for collection name, click on create. So this will create a to-do collection. So you can manually enter the data. So I'm just going to enter a few data, so a single data. So as you can see, I've just entered name 1, description for name 1. We'll also keep a couple of fields for date. Just mention create date. So we add a sample date for this. Okay, so this is the sample data. So select date wherever you want to maintain the particular list as a data string. Click on insert. So we have this data now created in the MongoDB. So So we can connect to this particular MongoDB and start accessing. So click on connect the cluster, and if you are connecting either through Compass, click on Compass. I'll be connecting MongoDB through Visual Studio Code, so I'll be selecting MongoDB for ES. You can either select shell or Mongo. So here you can notice that there is connection string available. Copy it into any notepad for now, as you might be reading this connection string later on. So now in this particular Visual Studio Code, I download the extension MongoDB for VS Code. You can see it here. It is MongoDB extension for the VS Code. So I'm currently in Visual Studio Code. So once you have the MongoDB installed, extension installed, click on connect. I need to fetch the connection string from the database, which I previously maintained. Let me get it for. So you can see now I'm connected to the MongoDB database, as you can see here in the notifications as well. So now either you can click on playground here, or you can click on go to MongoDB icon, click on create new playground. Basically you might have to enter a query. So I've currently used database task. So this is basically database. This is the task is database name and get collection to use. That is nothing but collection. So now if you query this details with a play button on the top, and you will see the response on the right hand side, which is the data which we entered in MongoDB Atlas. So now we have the MongoDB details created. So also please note that MongoDB Atlas has whitelisting of IPs. So make sure to whitelist your IPs there. So within the MongoDB Atlas, you can notice here there is whitelisting of IP that is available in add entries to your IP access list. So you can add your current IP address to make sure that you are able to access this particular MongoDB. Post that when you are configuring it in Google Kubernetes Engine, you might have to also get the external IP address of that and also add it here to whitelist that particular IP. So now we have the MongoDB setup. Now let's move on to Visual Studio Code. The Visual Studio Code, basically this is the React application is available in the link given below in the descriptions of the video. You can download this from the GitHub. So here you can notice that webpack.config.js, which is available under API. So there are two parts. One is UI and also there is API. I've currently just expanded the API, and you can click on the webpack.config.js, which is currently open there, and you can see the different connection strings that are maintained for the application. Please update the connection strings for all the sections relative to MongoDB database, especially the connection string for production, which is in line number 20. And once you update it, okay. So to Dockerize the app, let's build an image with a Docker file. So if you see here the Docker file, we have stage 1, stage 2, and stage 3. So stage 1, we are basically starting with base image node, that is 14 slim, and then we copy all React source files, and we install the dependencies for React, and then build the React app, and basically make sure all the build details are available in the given React folder, that is in the UI/UI. So in the stage 2, we basically start from the base image again, node 14 slim, and we copy all node.js package.json into /API folder. We install all the dependencies with related to node.js, and we build the node.js using npm install and npm run build. And in stage 3, we basically start from the base image node 14 slim, and we copy all the build files from React to UI/build, and we copy all the build files from node.js API into API/build, and we run the node API.bundle.js. So once we have done this, we have to install a extension called Docker, and once you have the Docker installed, you will have the Docker. Okay, so now we build the Docker with the Docker details, Docker file which we just created. So to build the image, we use docker build -t MERN image dot, and to check the images, we use Docker images. It will take some time to build the Docker. So I'll skip to the part where it builds the Docker. So we got previously we got few errors during the build is because the Docker was not available in the task bar menu. So we just have to launch the Docker and log in to the Docker if necessary. But we should have the Docker client running in our application. So we have the Docker client which is now available here, as you can see. Once you have the running Docker, as you can see here, your Docker container is running, and basically to run this particular Docker build command. So once we have this Docker build ready, we can check the images. It's going to take some time, so just skip to the part where it has created the Docker build. So here you can see the Docker images has provided me the image that is image that has been created. So the next part, so you can see the Docker images. You can see the image. You can run the container using the command docker run -d -p 8080 minus name. What is the name of the Docker image? Is MERN Stack and MERN image. So this will basically run the Docker, and then Docker PS will make sure that the Docker it lists all the setup for Docker containers, and we can check the logs using Docker logs for that particular image MERN Stack, and you can execute in the running container using Docker exec it MERN Stack /bin/sh. So here you can see the Docker image in the Docker client, and you can see the URL that is available, which is port 8080, which is HTTP default port. You can click on this particular link to launch the application, which is the MERN application. And this is a simple to-do app which is built on MERN Stack, and here it contains a simple inputs like task, assigning, task, status, and so forth. Back to the application. So here you can notice that we have done all the Docker related command executions. We are able to see the Docker client installed. I still see Docker exec is taking some time. It is throwing some error. So now we are logging into Google application. So with the Docker image ready. So once in the Google application, I'm just going to check the documentation. So we'll be running following commands. So one is we run the container using docker run, docker ps, so forth. So which we had previously done. You can launch the Google Cloud using cloud.google.com, and there are a few documentation with reference to this which you can refer to. But before that, we need to install Google Cloud CLI command language interface. So to install this, you can see here that it's available in this particular link. Click on the operating system you are running on. I'm using Windows, so I'll be using Windows to download. So you can see the link to download the Google Cloud CLI. Let me just download this. So before that, previously we had seen the Docker image being installed, and when we launch that particular Docker HTTP URL, so we'll be able to see the local host. And here, how do we know whether we have React as a front-end and back-end in Node.js? So we just create a couple of records. For example, the task I just created a create to-do list app for MERN Stack, and clicked on submit button, submit query. So post that. Once I am able to expand this particular screen, you'll be able to see the API request that goes to this particular application. So for example, so here you can see the API request. And for example, when we submit a query, click on submit query, you can see the API request, there is a post request, and you can see the contents of the request in the request tab. And here this particular dev tool in browser is available by clicking on F12, and once you select that particular post query, you will be able to see all headers, and this is the request for this particular post message, and this is the response we got. And so by this we can know whether the React, the front end, and the back end Node.js API is running properly, and we are getting the response from the back end Node.js. So next part is basically we will install the Google Cloud CLI, which allows us to run all the Google commands on our local machine, Google Cloud commands on the local machines. So once you have the Google Cloud installed, there are a couple of things which we need to do. One is we have to select the project for which we are going to use this particular application. So Google Cloud has different set of projects which is equivalent to resource groups in Azure Cloud. So every other resource is tied to the project. Once you delete the project, all other resources gets deprovisioned. So let's start with we have created a MERN Stack project. So here you can notice that we have used Google init, and then we have used and the other is Google login, that is Gcloud auth login. So which allows us to log into certain user details. It could be service accounts, it could be your personal Google account, as which needs to be in a which needs to have permissions for storage accounts, as well as the container registry and Google cluster, Google Kubernetes Engine as well. So we'll talk about that in the next set of discussions. So you can use this particular command called Google Cloud projects list. So it will list all the projects for this particular logged in account. And you can use Google Cloud config set any particular project, because every time you run certain commands, it will execute under that particular project ID. So yeah, so let's execute this, and you will be able to make sure that we are selecting the right project. Also in the UI, you will be able to check which particular project you have to select, and you can see here I have selected this particular project. You'll be able to see all the list of all the details that are available. And once you launch Google Container Registry API, so click on Enable API button. So it takes some time to update. You can also use Google command to update that particular flag. So the Google command to update the container register Google APIs to be enabled is Gcloud services enable container registry.googleapis.com. So we can use this particular command to enable it. We need to configure the Docker using Gcloud auth configure -docker. So now as you can see here, the GCI.io, us.gci.io, these are the Google container registers. And once you click on continue, the Docker configuration file gets updated. So next is basically next we build the Docker using docker build -d. We got few error in the previous run, docker build -d web dot. So we were not able to read the Docker file. So we just have to make sure that we are running this particular command in the portal location where Docker is present. Once you build the Docker image, we'll be able to see the Docker build, and these are the setup for the commands: docker build -d web dot. And the next part is we need to tag the image with register name, docker tag web gcr.io / the project ID. So just remember, it's not project name, it's project ID. MERN -stack is the project ID, and web app and the version of the application. So we keep it as v1. So this way we can tag the image with the registry name. So previously when we try to tag and push the image, previously when we used to try to tag, so just make sure that project ID is in small case letter, even though we have named the project with a different case. So just make sure you're using it in a small case letter for project IDs. So here you can notice that the container registry.google APIs was not enabled, so we just have to make sure we enable it. So I'm just running this particular command on my from a Visual Studio container, and also I'm logged in as a service account. So initially when you log into when you are using Google Cloud CLI on your local machine, so I've used so there is Gcloud init command, which basically initializes the Google Cloud, and basically next part is we authorize the Google Cloud command. So it will launch a browser application tool for you to authorize. Once you have authorized, it will show up different set of usernames for you to log in. So you can select a service account to log in. So you might have noticed that service accounts are needed in Google Cloud APIs. So you can just find service accounts in the Google main search, and you will be able to see you will be able to create a new set of service accounts. You may need to have service account to run and deploy objects to Google Kubernetes Engine cluster. The service account should have necessary admin permission on storage accounts, container registries, and so forth. Moving on to the next part is we use docker push image to GCP container registers. Make sure to add project ID and not the project name. So we use docker push gcr.io / the name of project ID, that is MERN project -386820 / web app, and version of the project, that is v1.3. So this is the tag name which we had created previously, and as you can see in the previous command. And next in the highlighted command we push this particular to GCP container registry. So once we execute this particular command, all the details are pushed to container registries. And once you launch the Google Cloud, select the project. So for example, here you can see one project. The ID is mentioned, which is highlighted there. So go to container registry. Type container registry here. So here you can see the web app, and then you can see the path, right? So gcr.io and the project ID and so forth. Here you can see all the pull requests for that particular details. So copy this particular pull by digest. You can use this to basically pull this particular Docker. You can use Google Cloud console application here as well. So I'm just trying to CLS, Google Cloud. Just want to increase the text size here so that it's visible to users. Gcloud Container Clusters create. You can use this particular command to create clusters. We'll have to specify the cluster name. Okay, so I need to provide at least one of location, zone, or region. That's fine. Let me do one thing. I can create this manually. So let me go into container registry. Sorry, let me go to GKE, this Kubernetes Engine. So we launched here. So enable the Kubernetes Engine API. Take some time to update. So this is to make sure that the API access is available for Kubernetes Engine. So basically it helps to build and manage container-based application using APIs. So now we have the Kubernetes cluster. Click on create. So it will provide a list of inputs that is required from the user. So we'll enter one by one. We don't need to create an autopilot cluster, which will spin up more nodes based on the requirements. So, but we'll just keep it to standard cluster. So switch to standard. Click on switch to standard cluster. So by default it is autopilot. So click on standard cluster. We just name the cluster to as per the application requirements. So just make sure to keep note of the cluster name which I have maintained here. So front end cluster. I'm just going to keep it as name as simple as that. So I'll just put a just identify this. So select the zone as your central one. Version. Keep the version and regular channel as it is. So click on the submit button. So it will take some time to clear the clusters. I got an error. Let me check. It's because I have insufficient regional quota to satisfy request. So I'm only eligible for 250 GB. So I'm 50 GB more in terms of SSD memory. So I might have to reduce the SSD memory to a little lesser. So I don't need. I just reduced it to 30. Now we see that there are setting is 3 nodes. We have the cluster creation is in progress. It's going to provision this particular cluster. You can click on different tabs with nodes to see the number of nodes that are being created. These are all the configuration which you can edit. So for now we can see no nodes are present. It will take some time to create those nodes. So under storage you can see the storage, health of the storage and so forth. So when you are creating the cluster, it uses Google storage. So the service accounts which is running this particular cluster should also have admin access to storage accounts. So just make sure that service account is having access to admin access to storage accounts as well as Kubernetes Engine as well as the container registry. Sorry, yeah. So now we have the cluster being deployed. I'll just skip to the part where it has deployed. So now we have seen the number of nodes that are created. The cluster is still running. So we just have to wait until the cluster gets created. So now the cluster is created. You can see that it is in green tick. So we can list all the list of all the GKE clusters using Gcloud Container Cluster list. And you can see all the cluster nodes are created and it's up and running with all the memory allocated, CPU allocated, and so forth. Let's run this particular command. Gcloud Container Cluster list, and here GKE Cluster list. The reason is because I'm running in a different account, which is user account, and I don't think I have access to this particular GKE clusters. I will have to use the service accounts. For that, I'm using service account impersonation in my Visual Studio Code. Let me launch the Visual Studio Code. Not authorized here as not using the service account here. I'm using the user account here. So let me just jump to. So here you can notice that you can type in this particular command, and here you can see all the list of all the clusters, Gcloud Container Cluster list. That's fine. So Gcloud Container Clusters list is the command which we are right now. So now I'm going to use Gcloud Container Clusters get credentials from fetching cluster command. I think so here the Cloud Container Clusters get credentials from front-end cluster -- zone US Central 1 project name, project ID which you need to provide. This basically configures the KubeCTL command to the GKE cluster, so that KubeCTL configuration is generated for this particular cluster called front-end cluster. And here we can notice that there is an error that we are missing a plugin, GKE-Gcloud auth plugin. So let's install this particular. So click on the link which is provided in this particular error, and you'll be able to get the command, and you can execute that particular command. Gcloud components install GKE Cloud auth plugin. So this installs this particular command, and later on GKE Cloud auth plugin version will make sure that you have installed it, and it provides the version that you are using currently. So that's the proof that we have installed it, and that's fine. So you can see the version details available here. And now let's go to Google Cloud and just search for Container Registry. Select Container Registry. You can see the containers being created here. So that's fine. You can see the Docker pull command by tag. So you can use this particular tag to pull the command. And here you can see the manifest file. So the manifest file is auto created, but we need to have a manifest file also created for web application. So this is the manifest file which we have created, and this manifest file contains all these objects which we are using as a web app. As you can see here, we have the container details updated here, and we have API version, then there is UI version, details. So just make sure we are updating the particular details here. Then, so once we have the manifest file created, so the manifest file is also available in the link which I provided previously. So we can use kubectl commands. So the first command which we need to execute is kubectl create -f manifest.yaml, that creates the objects based on the manifest file which we just created, and the manifest file is also uploaded to GitHub. You can refer to that, and you can edit it as per the application needs of yours. And then next part is we get to the deployment using kubectl get deployment. So it will just make sure to provide all the list of all the deployment done for the GKE Google Kubernetes Engine, and then we can get a list of all the pods running using kubectl get pod, and we can also get the service URL using list all the service URL using kubectl get svc. So let's get started. So now as you can see here, kubectl create -f manifest YAML. So the manifest got the objects got created when we executed kubectl get deployment to get all the deployment done. So we can see the web app that's got deployed. So we use kubectl get pods, and we see the number of pods that are running. There's about 5 pods. So one of them is the master node, and the rest of them are the set of subnodes, also called as nodes. So next part is we also list kubectl gets svc, and here you can notice there is cluster IP and external IP. So sometimes the external IP is not visible. Just make sure you are re-executing this multiple times until the external IP is provisioned, and you can use this particular IP and launch it in the browser. So once within the browser you launch, you can see the IP address I just added here. You can add set of tasks, assign, click on a set of assignees and so forth, and it gets created. That is all, and thank you for watching. Please subscribe, add comments to topics you want me to cover in future. I'll be happy to provide those new contents. If you like the video, click on the like button. Thank you.